Hey everyone, welcome back to Unit 7 or Unit 7A about exponents. So Unit 7 is about both exponents and logarithmic functions, right? So it's Unit 7A because our focus is going to start with just exponents. A lot of what you're going to see in this video lesson is review from things you ideally did in Algebra 1. There might be some more focus on some other skills, and hopefully you'll be able to recall and review with me. And if not, that this will be useful to you to develop an understanding of some of the properties of exponents, as well as how to simplify exponential expressions. So in this lesson, as I was just saying, we'll be able to recall properties of exponents. Maybe you already know some off of the top of your head, in order to successfully simplify exponential expressions. So exponents. In the expression x to the power of n, x is called the base. It's an important word. And n is called, maybe you guessed it, the exponent. X to the n, the whole thing is what we know as a power expression. So let's talk about some properties. X to the power of a times x to the power of b is equivalent to x to the power of a plus b. We're just going to go ahead and add the exponents. For instance, I'm going to build on this a little bit. If we had something like x to the power of 3 times x to the power of 5, this is x to the power of 3 plus 5, or x to the power of 8. The reason that this is true is that x to the power of 3 means that you literally have 3 x's. Right? So I'm doing x times x times x times 5 x's. 1, 2, 3, 4, 5. So you have right here 1, 2, 3, 4, 5, 6, 7, 8 x's. But if you multiply something by itself 8 times, it's the same thing as raising it to the 8th power. Right? So that's why it is true. On similar lines, we have x to the power of a divided by x to the power of b. Well, you might be able to infer, you might know that that is x to the power of a minus b. Again, let's say I have x to the power of 8 divided by x to the power, and you need the same base, right? So that's a key piece of this. If this was x and y, we wouldn't be able to do this. They have the same base, right? And so I think that's an important piece of this. I'll go ahead and write that. X to the power of 8 divided by x to the power of 7. By this rule, I should be doing x to the power of 8 minus 7, which is x to the power of 1, right? Or just x. What we have, just like I did up here, x to the power of 8 means I have x times x times x times x, 3, 4, 5, 6, 7, 8, divided by 1, 2, 3, 4, 5, 6, 7. And what we know we're able to do, I mean, we just simplified some expressions that looked like this, is I can just cancel a bunch of them, right? This is all multiplication. And I'm left with 1. So I have x, or x to the power of 1. Here what we have, this is when we raise a power to a power. Right, so this is the product rule, quotient rule. Power to a power, I have x to the power of a times b. Right, so this is like saying if I had x to the power of 3 to the power of 2, I actually have x to the power of 6. So let's think about that for a minute. I have x to the third times x to the third, which is I have 1, 2, 3, 4, 5, 6, right? 3 and 3. Oh, that's x to the power of 6, right? And this one, I want to make sure that I'm distributing the exponent. I'm multiplying here. If this was addition, if this was x, and you know this, you've dealt with things like binomials. If I had x plus y squared, I can't distribute that, right? We know that's not allowed, right? That's not legal. But because this is multiplication, I would end up with x to the power of a times y to the power of a, and there'd be nothing else I could do with that, right? So I'm distributing here. So for instance, if I have x, and these two rules could be combined, right? I could have x squared y to the power of 5. Well, that would mean when I distribute that 5, I have x to the power of 10, y to the power of 5. Right? How this works is, well, I have x times y times x times x times y times x times x times y times x times x times y, right? 1, 2, 3, 4. I need one over here. X times y. Well, pay attention to how many x's you have. I have 1, I have 2, I have 3, I have 4, I have 5, I have 6, I have 7, I have 8, I have 9. Oh my goodness, I have 10. For y, I have 1, I have 2, I skipped 1, 3, 4, 5. Right? So that's why it works the way it does. So these rules are always things that you can come up with as you're working as well. So to continue along with this, I have x over y to the power of a. I'm going to rewrite that. X over y to the power of a. Well, this same idea as before is x to the power of a over y to the power of a. If I have x squared over y to the third to the fourth, that means that I should have x to the eighth over y to the 12th. Right? And it's for the same exact reason, right? Here I would have x times x over y times y times y times x over y times y times y times x times y over y times y times y times x over y times y times y. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 y's. And I have 1, 2, 3, 4, 5, 6, 7, 8 x's. Now this one might be new. Might be. A negative exponent. Okay? So a negative exponent might be new to us. And so what this does is it actually, I mean, maybe you can think about it graphically as like we have a reflection that's happening, right? You're making the exponent negative. Instead of it increasing exponentially, something's going to decrease exponentially, right? So what this actually is it's an inverse variation. We didn't talk about these with rational functions, but this goes along with something with a rational function. We didn't talk about inverse and direct variation, but this would be an inverse variation. These would be direct, right? As the exponent gets bigger, the whole output gets bigger. For this one, as the exponent as n gets bigger, the output of this would actually get smaller. It would decrease. So x to the power of negative n is the same thing as 1 over x to the power of n. So I'm going to jump ahead to this one and come back and explain this one further. So what about x to the power of 0? Anything to the power of 0 is 1. So x to the power of 0 is just 1. Okay? That's all we've got there. So if I go back here for a second, I'm going to write this a little different. I'm going to say x to the power of 0 minus n. By one of the rules that we have on the previous page, we can actually, so I'm going backwards. I wonder if I can get there. So I'm going back to this one. I'm going to go from here, where I have x to the power of a minus b, and I'm going to break it up this way. And watch what happens. x to the power of 0 over x to the power of n. X to the power of 0 is 1 over x to the power of n. Isn't that pretty cool? Right? So we can use this over here. So for instance, if I had something like, what is 2 to the power of -2? Well, that's the same thing as 1 over 2 squared, which is 1/4. That's what that means. So that might be new. You might not have done a ton of work with that. And my guess would be that these two may be new as well. So fractional exponents. You may have had some exposure to them, but they might not be something that's super familiar to you. So what this means is that this is actually, if you're raising something to a fraction, it's just like taking a root. So x to the power of 1 over b is the same thing as the b root of x. So for instance, if I had x to the power of 1/2, that's the same thing as the square root of x. So we're actually able to simplify radicals by using some of these properties of exponents. Okay, so if something's going to get smaller, right, like if I have 25 to the power of 1/2, that's just 5. You might even be able to think about it as inverse operations, right? Like I know that in order to get rid of a 1/2 here, I want this exponent to be a 1, I would have to square both sides. Oh my goodness, I get 25 equals 25. So if this is the case, then this one also builds off of that. So what this does, if I have x to the power of a over b, it's the b root of x to the power of a. Right? I can kind of break this apart and think about it as x to the power of a to the power of 1 over b and combine some properties that I know. And so my base ends up kind of being x to the power of a. So for instance, if I have 25 to the power of 3/2, I have the square root, I don't need a little 2 there, of 25 to the 3rd, right? Well, the square root of 25, so these could go in either order, is 5 to the 3rd, so I end up with 125. So 25 to the 3/2 is 125. Okay? So let's do some practice with this. And I think this would be a really good place to maybe pause the video and see what you're able to do, see what you're capable of. So hopefully you've had an opportunity to try these and apply some of the properties of logs that of exponents that we just went through. And so by order of operations, the first thing I need to do is distribute this squared. So I'm going to go step by step. 17z times 3 squared z to the power to a power, this is going to be a 4. So I've got 17z times 9z to the 4th. So I'm able to multiply numbers how I already know how to multiply numbers. So 17 times 9 is 170, 163, I think. 17 times 9, right? 153. Yeah, sorry, 153. And then when you multiply and they have the same base, you add their exponents. Z to the power of 5. Start this off the same way. Let's go ahead and distribute this exponent. So 5 to the 3rd gives me, I just did that one, 125. X to the power to a power, that's 6 over 100 x to the 5th. Well, these right here, that doesn't highlight terribly well, but that's okay. Simplify. Right, 125 divided by 100, I can divide them both by 25, right? And this would be 5 and this would be 4. Right, divide them both by 25. And then x to the 6 divided by x to the 5th. Well, if I have 6 x's in the numerator and 5 in the denominator, I just have 1 left. If you want to write 5x over 4, if you want to write 5/4 x, those are the same. They're both great. Okay, so let's see what happens here. So just be careful that a is in the numerator, b is in the denominator. I can't start canceling things. They don't have the same base. So I'm going to start off by distributing the exponent and distributing the exponent. Okay, so this is going to be a to the power of 55, power to a power, over b to the power of 55. And now we're multiplying b to the power of 63 over a to the power of 49. Now it's multiplication. If I want to write it over one bar, I can. Sorry, that's a b. And then I'm able to actually do some simplification here, right? So I have this a and this a. So I'm going to end up with just a to the 10th, right? 55, this is 49. I can't read my own handwriting. So that would be what, 6? And then I can focus in on the b's, 63 and 55. I have 63 in the numerator and 55 in the denominator. I'm going to have just 8 in the numerator left, b to the 8. Right, not too bad. Let's do some more, right? So if you didn't pause it, these get a little bit more challenging. I would maybe try to pause now and see how you can do with these. So for this first one, I'm actually going to simplify since all of this is in the parentheses. I'm going to simplify it before I make it bigger with this 6, right? I see things that will simplify. So 10 divided by 5 is 2. And then I get p to the power of, what will that be? 9. And n to the power of 2, right? So I can make it a lot simpler for myself right away. And then I'll go ahead and distribute. Make sure that you're not forgetting to distribute to the coefficient, right? That's still there. That's a common one to forget. So I end up with 2 to the power of 6, p to the power of 9 times 6, which is 54. Imagine having done like 12 times 6 or 10 to the 6. Like that's not math you want to have to deal with, right? So just like we did with rational functions, simplify first. And then 2 to the power of 6, let's think about that. You might know it, right? 2 times 2 is 4, 8, 16, 32, 64. Right? 2 to the 6 is 64. P to the 54th and to the 12th. If you're able to make things simpler first, smaller first, do that. This second one, be careful here. These are not the same base, right? This is a 64 and this has a base of 6. This, like, they can't be combined, but I can work with these two, and it's a cross multiplication, so it's totally allowed. So I've got 64 over 3, which you might know. Doesn't simplify, does it? No. And then times 6 is your base, you're subtracting these, so times 6 squared. Right, 1776 minus 1774. I'm not going to write all of those out. That's a lot of 6s I'd be writing. All of them will cancel but 2. So that ends up with 64 times 36 divided by 3. And I believe 36 divides nicely by 3 because you get 12, right? So you can do 64 times 12, which is 64 times 12, 8, 12, 138, 4, 6, 8, 7, 7. Nope, I'm adding wrong. 8. This is a 2. 768. Whoa, that whole thing is just 768. Pretty neat, right? And then in this last one on this practice, this is the first time we're seeing negative exponents. Okay. So what I'm going to do here is I'm going to actually distribute that 4 first. Okay, what I'm going to do with this whole thing is I'm going to move this whole thing to be 1 over so I can deal with that negative exponent. So I've got 5 to the 4th, a to the 12th, b to the negative 8, we're going to have to come back to that, times 1 over 5 squared. It's no longer negative because I did 1 over, right? It changes to a positive when you do that. A to the, oh no, that's still negative 8 though. B to the, what is this? And there's different ways you can approach this. You might not be doing it the same way I did. I don't know that, maybe it wasn't, I don't know. And then I've got 5 to the 4th. I didn't do that because I know that there's a 5 squared in the denominator. So I'll be able to kind of deal with that. When I multiply straight across, right, that's like over 1. I have 5 squared, a to the negative 8, b to the negative 10. And so if I were to write this whole thing out, focus in on the 5s, 5 to the 4th divided by 5 squared, it's going to be 5 squared. A to the 12th divided by a to the negative 8 is going to be a to the 20th. Okay. B to the negative 8 minus, I'm sorry, divided by b to the negative 10 is going to be, so negative 8 minus negative 10 is going to be what? 2. So maybe I didn't need to deal with that fraction. I probably could have distributed the negative 2, but I figured why not? We could take a look at what happens there. So I end up with 25a to the 20th b squared. Hopefully I didn't make an error in that. And again, if you approached it differently, it's okay. It's absolutely acceptable as long as you're arriving at the same final result. Let's do a few more. I think these are our last 3 examples or practice we'll do together. So I'm going to write this out as division. 1001, x to the negative 4th, y to the negative 3rd, divided by 77, x to the 6th, y to the negative 7th. So let's see, does 1001 divide by 77? I feel like yes, right? If it ends with a 3, so it's got to be 13. Yeah. So when I divide those two, I get 13. X to the power of negative 4 minus 6 is negative 10. We're going to have to deal with that in a moment. Y to the power of negative 3 minus negative 7. That's like plus 7. I get 4. So I don't want to leave this negative here. I'm going to move it to 1 over x to the 10th. So I end up with 13y to the 4th over x to the 10th. Whoa, check out that second one. I want to deal with these negatives right away. We want to move them up and make them positive, right? So I can do the 1 over, which I'm not going to, I could sit here and say, oh, 7 over 1 over x to the 5th. Then that's just 7 times, instead of dividing by a fraction, multiply by the reciprocal, right? So I actually, for this one, have 7x to the 5th minus 4x. There's nothing I can do. Nothing. That's it. You were subtracting. I can't subtract those. They're not like terms, right? This is an x to the 5th and this is an x. You know that they're like not like terms. If you were able to combine those, then every single time we were dealing with a quadratic, you would be able to combine these two, and we didn't. We know that. So go back to your roots with that. Let's take a look at this last one. So I've got 3 to the 4th, which I'm going to leave for a moment. This, not so scary. When something's raised to the 0 power, it's just 1. Right? So I've got a to the negative 7, b to the 3rd, d to the negative 4th, divided by a to the negative 4th, b to the negative 5th, c to the 6th. And let's do some simplifying. So 3 to the 4th is 81, right? That's like 9 squared. A to the negative 7 minus negative 4, so that's negative 3. B to the 3 minus negative 5 is 8. D, nothing happens with it. And then C, nothing happens with it, right? I want my exponents to be positive, so I'm going to have to shift things around, right? My A is going to have to go in the denominator. So B is the only one that can stay up there. The other ones are I'm going to have to do the reciprocal. So it would be A to the third, C to the sixth, I'll leave it, it's already positive, D to the fourth. And this would be my simplification of what I started with. Woohoo! Oh, I had two more. So sorry. I thought I was done. Okay. So let's see. Oh, of course, we have to do some fractional ones. So same property here. And so I'm going to go ahead and distribute the negative 1/6 and distribute the negative 2/5. So 64 to the negative 1/6, x to the 2 times negative 1/6 is negative 1/3, times 32 to the negative 2/5 times x to the, that ends up being negative 2. Okay, everything is negative, so I might want to just say it's 1 over all of this, right? So I might want to start with that so that I don't have to deal with a negative. Okay, so let's see. This is the same thing as the 6th root of 64, right? So like what times itself 6 times? We've actually already done this one today, or in this lesson. This is the 3rd root, the cube root of x. This is the 5th root of 32 squared. And this is just x squared. Okay. I don't actually know that I wanted to change this, but that's okay. So the 6th root of 64 is 2. I'm going to leave the 1/3. I'm going to go back to it, sorry. For this one, I don't want to do 32 squared. That's a hard thing for me to do in my head. So if I want to do the 5th root of 32 squared, like I can, it's just, that's not, maybe not things I've worked with so much. So I basically want to treat this as I want to do the 5th root of 32 and then square it. Because I know that the 5th root of 32 is 2, squared is 4. So that's just 4. And then this is x squared. So here I've got 1 over 8. And then, oh, I'm multiplying and I have the same base, I can add them, right? So this can be 6 over 3. So I've got 7/3. X to the 7/3. Maybe I don't want a fractional exponent depending on what the question's asking. And so maybe I would say 8 cube root of x to the 7th, right? This would just depend on what exactly is the question asking, right? So you need to look at when you simplify, you don't want negative exponents. When you simplify, you don't want fractional exponents. Like that would come from directions in there as of how should I express my final answer. All right, that was loaded. So this is going the reversed way, right? So instead of me taking the 5th root, well, that's the same thing as raising it to what power? Hopefully you're saying the 1/5 power. And then I'm able to distribute, and I've got m to the 6th, k to the 32/5. And again, this would come from a place of what exactly is it asking for? This might be how I express my final answer, or maybe it's m to the 6th times the 5th root of k to the 32nd. That would come from how does your final answer need to be expressed? And again, that would come from directions. So I'm not going to go through this, but this is the supplemental worksheet that is, or part of the supplemental worksheet that is posted. There's actually another video that is kind of like a video answer key to a few practice problems, or I think this page actually. So this would be a really good resource to use to practice, and then you can check the key as well as the video key to see how you're doing. So throughout this video lesson, we recalled properties of exponents, many of which you have had exposure to in the past, and some of which that you may have seen but not worked with nearly as much as we will in this topic and in this unit. To successfully simplify a variety of exponential expressions, including negative exponents, fractional exponents, zero exponents, and just using these different properties. So hopefully this was a great review for you, and you can go and use some of the resources to make sure that you have a solid understanding and you know what questions you might have that you want to ask when we see you next. Thanks everyone for watching, and we will see you next time.